Welcome, friends. Welcome to this second part on the introduction to field studies. In the first part, we attempted to understand that by studying engineering, we were actually studying basic forces of nature, modeling them, and creating systems which did work for us. Here, we are going to be a bit more specific about electromagnetic fields. So we'll be answering two questions. What makes the study of EM tough? We are going to right away answer these questions. Along with that, I am just going to give you what are the significance of EM studies. What is the need to study it? Rather, as a student, if you understand the significance firsthand, I feel that it will be a very big motivation for you to study the subject. As it is, if you complete the bachelor's course and get into any specific electronics electrical domain, you will feel the significance. So, in that fashion, I feel that let me try to give the significance firsthand itself. So, let's enter into it. Everyone says study of EM is not that easy. Is it so? My answer is true. But EM study can be made easy if we know why it is difficult. So, let us just try to understand the answer as to why it is tough. To understand this answer, it is better that we go into the philosophical domain. I am not going to talk too much of philosophy because even the scientific community has accepted this philosophical definition of what makes EM study tough. Everybody knows that there are five basic elements in nature. Let me just try out a small diagrammatic explanation. What are the five basic elements? Earth, water, fire, wind, and Akash. Akash is also called as the cloud. Now, we understand that all the things in this world are composed of these five elements. And these five elements, in varying proportions, are responsible for the perceptions like sound, vision, touch, smell, and taste. So, these perceptions are observable by human beings. How? We have the five sensor organs ear, skin, eye, tongue, and nose, which can perceive these effects and enjoy them as well as declare them it is disturbing. So we can make decisions based on that. Now, the idea of electromagnetism, it is accepted to be present at the top of this triangle. I'll tell you why I went for the triangle representation. When I mean that it is at the top of the triangle, what I am trying to tell is EM doesn't create any perception, right? Or rather, I can tell that the human body doesn't have any sensor organ that can detect the perceptions created by EM. So, EM is placed at the top of this triangle. The triangle has a broad base and it just narrows down. The triangle explanation is because of two things. First of all, let me just think we don't have a sensor here. So, I'll put two arrow marks like this. This way, I call it abstraction, and this way, I call it materialism. Materialism or physical. This is an accepted model both by the spiritual and the scientific community. Perceptions like smell and taste, they are a big physical effect. So, from the triangle, as we go up, the perceptions become more and more abstract, and as we go down, it becomes more and more physical. What is the direct implication? As it becomes more and more physical, you have got sensors in your human body that can detect it. Once you have detected it, you can easily understand the field, model it using the available mathematics, and create systems. Typically, let me take an example of thermodynamics. Thermodynamics relates with the heat. Heat is something related to fire. Fire creates vision and touch. You can feel the heat through your skin and you can create models comfortably. On the other hand, EM, which doesn't create a perception, you don't have any sensor to detect it, it is your mind's responsibility to model the systems. This is a holistic answer accepted by both the communities, both spiritual and scientific community, in trying to understand why study of EM is tough. So, any field study, we can study the fields by observing the effect on an object, right? If the object gets heated up or lights up or makes sound or elongates, these are all physical effects. As long as the effects are physical, you can model them easily. But in the case of electromagnetics, in due course of time, you will hear a term called electrical charge redistribution. What is it? Science has stated that all the objects are made up of atoms, which in turn are made up of protons, electrons, and neutrons. The application of electromagnetic field doesn't elongate the object or makes any sound or lights it up. It just makes a small charge redistribution or a rearrangement of atoms. And this rearrangement is cancelled the moment the field is not there. So you don't have any physical effect that is to be observed, which makes the study very, very difficult. I would like to give a small note of caution. If this electrical charge redistribution goes beyond a particular point, it burns. The object gets burnt away. So, summarizing it, what makes EM tough? Its abstract nature. And what do you mean by abstract nature? You have to apply your mind and model the max, not observable by human body senses. This is the biggest problem. It's not a logical subject. EM study, it is nothing but a thinking process that has to be initiated by the teacher and with full cooperation by the student. This is what we could summarize as study of electromagnetics. This is what makes EM appear to be tough, but it is not a tough subject. It only requires heavy thinking process. EM effect. The percentage EM is based on the big thinking process created by Maxwell, Bose, Marconi, Hertz, Tesla. You can include Faraday, Volta, Ampere, Oersted, Gauss. I have left out them. But it has been realized in various ways in various ages. You need to know this. The Indians, the Chinese, the Greeks, we all have done big, big astronomical calculations stated in our ancient texts. Unfortunately, we are not able to tap them and understand their full depth. It is the most significant effect ever realized by humans. And we could finalize it like this: EM is complex because you don't have a sensor to detect it, but it is not at all complicated. Once you have clearly understood it, it becomes such a beautiful subject to study. The physical idea discussion is what the most important thing in EM studies. So I feel we have answered the question as what makes EM tough. Physical answer is no sensors, you have pakka application of your mind. Now let us get into the second thing. What is the big deal in studying this? What are the significance of EM studies? The right away answer to this thing is it provides a background explanation for many applications. This is another issue. When the application works very well and everybody is okay with it, there are no issues. But if something goes wrong, the entire blame goes back to EM studies. That's why I'm putting it in green. Provides the background explanation for many applications. This is to be understood by the student. There are no front-end effects of EM. EM is at the background. So, what are the phenomena or things that are explained? Let us start like this. Cell phones, basic operation, radio, TV broadcast, all wireless applications. On the front end, you may have a basic cell phone, but how does it operate? Electromagnetic field. You don't have anything, you have to enter into that domain. Simple car lock, which you are doing daily. You are opening the car from a distance. You enter into an hospital, you are entering into a world of electromagnetics with all the medical diagnostics like X-ray, CT, MRI, a microwave oven in your house, the airport scanners, and many, many more. I would just list out these things as applications which we can feel directly. Now, applications that are not felt directly, these are all quite heavy industry, remote sensing, Oil exploration. Have you ever wondered how do we know that there is oil in a place? We can't go and dig in each and every point. Weather monitoring, navigation, it has become a big thing now. Everybody uses Google Maps as if nothing is happening. Right? It is a biggest example. Who connects you directly and to the satellites and servers, and how are you able to navigate your way? This is another big thing, relief and rescue operations. EM communication during natural tragedies. At present, if you have the NDRF team of India, the moment an earthquake happens in an area, the first activity done by them is going there, establishing cell towers, because that gives you immense coverage. At a big commercial level, Elon Musk's Hyperloop is an electromagnetic technology that aims to reduce travel time, isn't it? So they say that the distance from Bombay to Dubai can be done in, say, half an hour. Then you have the biological effects, which is a very ambiguous area, and the list goes on. It's completely unavoidable study required for complete understanding of engineering. So these are the applications, and this is not the entire list. Now, for an academic understanding of electrical engineering phenomena, right? As long as you are in this 4 years of engineering, you should know this. Can we design an amplifier using Maxwell's equations? The direct answer is no. You don't need them. But you will be studying certain things called Kirchhoff's current law, Kirchhoff's voltage law. If we do a thorough mathematical study, you will know that they are just approximations of Maxwell's equations. Right? VLSI algorithm. To design a VLSI algorithm, do I need to study EM? Absolutely not. You don't need to study EM for doing VLSI algorithms. But when a trouble comes, you need to know that there are many issues called EMI, EMC for a device which requires field studies. If the algorithm doesn't work well under certain conditions, it goes back to electromagnetics. So these are just some academic things that you need to know. I would like to conclude saying that EM concept has remained intact for the last 150 to 200 years. What has been developed by Marconi, whoever you called as Faraday, Volta, Tesla, nobody has attempted to change it. Concluding is EM is quite complex, but it is never complicated. So that finishes this video part on Introduction to Field Study. Hope I was able to successfully create an interest in studying electromagnetic fields and right away giving you the challenges that you will encounter. Thank you. Let us just finish it off. EM is a complete mind application and a small assignment to everyone. Gravity, as it is, has been said that it is due to Earth's magnetic field. So we are affected by gravity. Does that mean that human body has magnetic sensors? It's a good point to ponder, isn't it? So thank you.